Welcome to Homework Lib.
We have to simplify the following equations. So first of all, let's notice the parts that are together just to keep everything in order. So we're going to have this red part and this purple part. So from the first part after doing the multiplications, what we're going to get is from the first term e to the minus I omega t minus 1 times c1 conjugated times c2 plus the product of e to the I omega t minus 1 times e to the minus I omega t minus 1 multiplied by c1 complex, cy complex again, c2. This is going to be the contribution from the red part. Now from the purple part, what we're going to get is e to the I omega t minus I c1 C2 conjugated plus e to the I omega t minus 1 multiplied by e to the minus I omega t minus 1 and the product of C1 conjugated C1 C2 conjugated. And what I want you to notice here directly is that this is nothing but the sum of two complex numbers, right? This is the same as set and set conjugate. You can analyze it term by term. Over here, this part is the conjugate of this part, and over here, after conjugation, you arrive to the second part. So whenever we add up set plus set conjugate, what is going to happen? It's going to be that this is going to be equal to 2 times the real part of set directly. So what I'm going to do is just simplify a little bit the expression for set for the first number that we have. The first term is going to stay the same. It's going to be the same e to the minus I omega t minus 1, c1 conjugate times c2. Just a disclaimer, you can directly put 2 times real part of all of this number over here, and that would be enough to simplify it. But just to be more thorough about it, we're going to decompose the exponentials as cosines and sines and see what is going to happen. Okay? So now the second part, we're going to have the constants times c2. And the product over here, what we're going to have is e to the I omega t times e to the minus I omega t. This is going to be a 1 minus e to the I omega t minus e to the minus I omega t plus 1. This is going to be the product over here. Okay? Now what we're going to do is decompose it a little bit. The exponential you can write it down as cosine of omega t minus I sine of omega t multiplied by, over here before the multiplication, minus 1 multiplied by c1 conjugate times c2 plus c1 times c1 conjugate is going to be c1 squared times c1 conjugate times c2 multiplied by a very big factor that I'm going to write down in parts over here, 1 minus cosine of omega t minus I sine of omega t minus cosine of omega t plus I sine of omega t plus 1. Over here, you're going to notice directly that this minus is going to cancel out, and we're going to end up with a factor corresponding to 2 times 2 minus 2 cosine of omega t. Okay, so now the expression for set is going to be cosine of omega t minus I sine omega t minus 1 times c1 conjugate c2 plus C1 squared times C1 conjugate times C2 times 2 multiplied by 1 minus cosine of omega t. And now, to ensure that we're going to keep correctly the real part of set whenever we want to do our original result over here of set plus set conjugate, what we're going to do is to decompose C1 conjugate. This is going to be equal to real part of C1 minus the imaginary part of C1. And whenever we multiply it by C2, this is going to be times the real part of C2, sorry, minus I times the imaginary part of C1, plus I times the imaginary part of C2. Okay, so the product is going to be real part of C1 times the real part of C2 plus I times the real part of C1 times the imaginary part of C2 minus I times the imaginary part of C1 times the real part of C2. And finally, minus and plus is going to be minus, but I squared is going to count for a plus the product of the imaginary parts of C1 times the imaginary part of C2. So now with this, what we can do with set is to factorize the C1, C2, well, C1 conjugate C2 factor that we have in common on both parts. And this is going to multiply the very big thing that is going to be cosine of omega t minus I times sine of omega t minus 1 plus C1 squared, sorry, plus 2 times C1 squared multiplied by the 1 minus cosine of omega t factor. Okay. Notice that this section over here, we can classify it as a part that is real and a part that is going to be imaginary. So this is going to be equal to 2 times C1 squared times 1 minus cosine of omega t plus cosine of omega t minus 1 and minus I times sine of omega t. Just to simplify it a little bit. And now when we want to take the real part of set, this is going to be equal to the real part of the product C1 conjugate C2 multiplied by the real part of the factor that we have over here, which is 2 times C1 squared 1 minus cosine of omega t plus cosine of omega t minus 1 plus the imaginary part of C1 conjugate C2 times sine of omega t. How do we get the result? Remember that the imaginary part of C1 times C2, what we can look at it is I times the imaginary of C1 times C2. So whenever we multiply this factor with minus I sine of omega t, this is going to be directly minus I squared imaginary C1 conjugate C2 sine of omega t. Okay, so I squared is minus 1, minus I minus is going to be plus. So that's where that part comes from. So with that, that should be enough for getting the real part of that complex number. If you want to express it directly, you can employ the section that we got here for the product of C1 conjugate times C2. So from here, what we know is that, let me put this as the result, just for, and remember that the real part of C1 conjugate times C2 is going to be equal to, according to this section over here, real parts plus imaginary parts as products, right? So real part of C1 times real part of C2 plus the imaginary part of C1 multiplied by the imaginary part of C2. Recall that over here, I took care of the conjugate with the minus on this section, if you remember correctly, okay? And the imaginary part of that product, or to be more precise, I times the imaginary part of that product is going to be I times multiplied by the factor real of C1, imaginary of C2. Let me erase this small dot over here. Real part of C1, imaginary of C2, minus imaginary of C1, real of C2. So real of C1, imaginary of C2, minus imaginary of C1, real of C2. So with that, we have already the result because we already found earlier over here that this expression was 2 times the real part of set, as we defined over here, because we have the sum of two complex numbers. So the final answer is going to be, for the simplified expression, 2 times real part C1 conjugate times C2 multiplied by 2 times C1 squared 1 minus cosine of omega t plus cosine of omega t minus 1 plus the imaginary part of C1 conjugate times C2 multiplied by sine of omega t. So this is going to be our simplified expression for the result. And over here, everything on square parentheses. So with that, thank you very much and have a good one.